All right. Remind me to start recordings if you do not see the session is not being recorded, because I might forget sometime. All right. Great. Great. Hi Akash. Hi Anil. Hi Balvinder. Hi Josephine. Hi Nand Kumar. Hi Patrick. Hi Ravindra. Hi Tracy. All right. All right. There are a few good questions. Let me try to answer those, and then we will continue our discussion. All right. Any other questions do you have? All right. The only way to learning is by asking questions. So feel free to ask questions. Otherwise, do not worry about course being delayed, my flow being broken. Don't worry about that part. All right. Okay. That I can manage. No worries. All right. And don't worry about that. Your question may not be great question. Every question is a good question. Okay. Good. All right. All right. A question. First question is internal table and external table. How we can differentiate them? Okay. The first differentiation is that you can simply say describe, formatted, and table name. Whatever is your table name, you on the hive prompt or in the hue, you can type this, and that should give you the answer. All right, does it make sense to you? Great. All right. And the other question was, let me copy all of the questions here. Okay. Okay. All right. Please ask questions. Okay. That's the only way to learn. All right. So the second question is loading data from local and HDFS into internal and external table. What happens? Actually, the process is same. Okay. The process is same for both, whether internal or external. Okay. Okay. The process is same for both internal and external. All right. Good. Good. The process is same as in why, so what happens when we create a table? Create a table in Hive means an entry in the meta store, okay? Entry in the meta store, like what is the table name, what are the columns and all that, plus creation of a folder, okay? Creation of a folder in HDFS if it doesn't exist. All right, this is what happens when we create a table. And when we load the data, what happens is when we load the data into a table, what happens is load the data from local. I'll take one case at a time. Okay, the file get uploaded. Okay, and when you load the data from HDFS. Let me take this case. Let's say there is a file in HDFS and we want to load that file into our table. So what happens is the file gets moved into location of location of Hive table. Okay, so creation of a folder, this one, please note this one. This is the location, of the table, and whatever data you load, that file get moved to this location. All right, that file get moved to this location. That's all. That's all. Okay, if there is a in that folder, if there is already a file with the same name which we are which you, it is trying to move, then it gives it 1 2 3 and so on kind of suffix. All right, next, load data from local. Okay, load data from local. So all right, so what happens in case you load the data to local? Okay, the files gets uploaded into HDFS, and then same thing what happens in case of load HDFS. Okay, so then this file gets moved to the location table. All right, good, so far good. Is everybody clear about this? Okay, next question is how can we save the result of query in Hive? Okay, so we talked about this where we can save. Okay, I will show you this. So if you go into Hive, all right. Okay, so there is one slide where we talk about loading and saving the data. Okay, here is the loading part, and here is the saving part. So you can always say insert overwrite local directory and give the directory name, and all this data gets saved. Okay, make sense to you? All right. Next is create table. Okay, only create table, new file, select star from old file, only creates empty folder in this. How can we save the result? Create table. No, actually it should create table, new table name. Okay, it should create the data, create a table using this. All right. In Hive, while creating a new table from a file, the file is uploaded into HDFS. The original file affecting means it does not belong to HDFS anymore. Why? No, I did not get this question. Let me try to read it again. Okay. In Hive, while creating a new table from a file, the file uploaded from HDFS, the original file affecting means it does not belong to HDFS anymore. Generally, when you load the data from HDFS file, it gets moved to newer location. If that clears your doubt, or could you ask the question again? All right, great. Next question from Nand Kumar is the DFS is the suffix for all command in Hive? For example, yes. Copy from local, CP, move from local, and all that. All right. As per their claims, it does seem to work. Great. Great set of questions. Should we move on? If you have any questions at this point, please feel free to ask. All right. All right. Feel free to ask because the only way to learn is by asking questions. Okay. Not the right question, any question. Okay. Because I do not emphasize on asking only the right questions because people don't know whether the question is right or wrong unless they ask it. All right. Please feel free to ask. Okay. Don't worry about breaking the flow, breaking my agenda. All right. I can manage all of that. Great. Okay. Great. So looks like there is no question as of now. Okay. I will keep it little. Mhm. Okay. How do I keep this? Remind me to convert. Window, bring all to front, options, added, file, go to meeting. I'm trying to figure out how can I keep it on the top. Okay, so far there doesn't seem to be an option. Alright, never mind. So I'll keep checking the questions from time to time. Alright, again welcome to today's session on NoSQL and HBase. Before we go forward, I would like to explain what does it mean by scaling out and or horizontal scaling. Let us say there was a person who has one cart with a single horse. After a point of time, he needed to carry bigger load. So he had two choices. One, add an elephant or a bigger horse into the cart, or add multiple horses into the cart. Okay. So when you add multiple horses into the cart, it's very similar to having uh, it's called horizontal scaling. And when you replace the horse with an elephant, that's called vertical scaling or scaling up, right? All right. Now, if we take the same analogy for our systems, a, a, a computer, when we increase its RAM, increase the CPU, or change its hard disk, that's called horizontal, vertical scaling, meaning we are kind of replacing the horse with an elephant. All right. And replacing a horse with multiple horse or adding more horses is called horizontal scaling. And in our typical sense, that's what we are trying to do. When our computer could not solve our problem, we added more computers in the network so that all of these computers can solve our problem together. All right? Scaling up was is a easier choice, okay? Because you can leave the same cart and add a bigger animal in the cart. Similarly, you don't have to change the architecture of your application. You can simply upgrade the server, okay? But it doesn't scale. Tomorrow, if elephant doesn't suffice your work, do you wait for dinosaur to come, or what is it that you will do? Okay, or you will wait for, or you will buy the costliest elephant available, but that will give you hardly marginal difference of 10% or 15%. All right, so I think this story, I think this story about RDBMS will give you a better clarity on why do we need NoSQL or why do we need anything. Okay, this is a very important story, and all of you should pay close attention to it and ask me doubts if you have any confusions about this story. This is the true story, and many companies struggled and shut down because of this. This was the main cause of lots of companies to shut down. And the companies like Amazon, they also lost a lot of business a year, but they recovered and they created no sequels like Amazon Dynamo. Okay, we will go into this story and try to understand why do we need NoSQL in first place. Let's say you are a great developer and you are a great motivated entrepreneur and you build this great application, or you are a great project manager in a great company. You build this product and you are launching it. So you move your database from local database to, you move the data from local to a network, and then you say that it's a public launch. All right, and you have this champagne party, all the PR and the news coverage and so on. And afterwards, services starts becoming popular, and suddenly you realize that too many hits are hitting your database. So the first knee-jerk reaction or first immediate action is from almost every great developer on the planet. The first step they do take is add a caching layer. What is a cache? We prepare we prepare an intermediate data, okay, or you can say we pre-prepare data, okay, which is used very often. That's called caching. We pre-prepare all the data, or we keep the data which is very frequently used in the memory. All right. Okay, so adding a memcached, which is one caching layer, is a very straightforward process. And the only downside of such an approach is your reads are no longer acid. What does it mean? What does it mean by reads not being acid? Okay, let's try to understand what does it mean by acid properties. Acid properties are generally kind of must in relational database. A for atomic, A for atomic, C for consistent, and I for isolation, and D for durable. Now when you put caching layer, you have an intermediate layer which contains you have an intermediate layer of the data, which means whenever there is a change in the data, this intermediate layer needs to be updated. Okay, let's take a case of Amazon's detail page. This detail page of every product is generally cached. Lots of data is generally cached, and when somebody changes the detail page, somebody updates the title, the page has to be invalidated and re-prepared. But by the time it gets re-prepared, we are serving the old page, and there's always a difference between data modified and data prepared or data cached. And therefore, some users will still see old data, and hence it's not strictly consistent, right? So the first thing that happened in this firefighting, the first thing that has happened in this firefighting is we lost consistency. Okay? Doesn't sound great for anybody from relational database background. Next, your service is still growing popular. And when your service is growing popular, although it should be a great news for all the sales and business development people, for technology, you are being hit. There are too many writes hitting the database. Okay? So what you need to do at this point is the if you have got money, then what you will do is you will buy really high end hardware, such as the one with 16 core CPU, 128 gigabyte RAM, and banks of 15,000 RPM hard drives. Okay, and this is only possible if you have got great VC fund, all right, or your company is really rich. Now you are pretty happy about your hardware upgrade, and since you have got some money, you started, building more and more features. And whenever you build a new feature, let us imagine that in the beginning, if you are to launch an e-commerce website, in the beginning there'll be a title, there'll be a product description, and there'll be a buy now button. When, as you grow, as you realize that okay, now we have bandwidth to make more better experience for the user, you start adding product image, you start adding variations like blue shirt, yellow shirt, and red shirt, and those are called variation. And then you start adding more features such as the byline, as in the who is the author of this book, or who is the manufacturer of the product. You can click on them, and so on. Now because of this, and whenever you are adding a feature, because of adding a feature, you end up having new tables. You will have more tables than what were earlier, because the way we implement a new feature is we create a new table with the same primary ID, product ID being common in all. And when we need to prepare the product page, we will basically do the join across multiple tables, and whatever is the result, using that we will render the HTML of the product detail page. So what you see here is that since there are too many features, the query is becoming bigger and bigger, and it's basically big. There are many joins. Okay, there are many joins because of the features. So you come up with this idea: what if I merge all of this data into a single table, meaning I denormalize lot of data. I denormalize, and at this point, if you have a DBA or you are from a DBA school, you will be shocked that what are we talking about? We are talking about denormalization. That is the second most important thing a database provides. Database, that's what we learn. Half of my life, I learned about how to normalize tables, and rest half, how to denormalize them. So we lost second important thing. First important thing were acid properties, and second important thing was normalization. But still, the problem is not solved. The database, the rising popularity keeps on swamping your server, and things are still too slow. So you stop doing server-side computation, but again, server-side computation such as stored procedures, triggers, and whatnot. Okay, some queries are still too slow. Some queries are still too slow. So you periodically pre-materialize them, meaning you prepare the result, and again you stop joining in most case. But now at this point, reads might be okay, but writes will get slower and slower. Why? Because you have too many indexes. You have prepared indexes to optimize your queries. Some people are looking for a shirt based on the size. Some people are looking for the shirt based on the brand. Some people are looking for the shirt based on the color, and so on. Therefore, for making the filters fast, you had created so many secondary indexes. Now, since writes are slow, and how does having two how does having many indexes make write slow? Because every time you modify a record, every time you change a record, all the indexes need to be updated, right? When you make certain changes in a book, when an author of the book makes certain changes in the book, the index on the back side as well as index on the front both need to be updated. Correct? Therefore, more number of indexes will lead to slower query, slower writes. Therefore, you stop having secondary indexes. Now, this is again this is again a step backwards. All right. So what all we lost? Fun. First thing we lost was the consistency. Second thing, normalization. Third thing that we lost was server-side computation, such as stored procedures. And fourth thing we lost was secondary indexes. Now, now, when people realize this at Amazon and everywhere, they ask the question again to themselves that in a high throughput environment, when you need faster writes and an enormously huge number of requests per second to be handled, do you need database? Why do you need database when you don't need normalization, you don't need consistency, you don't need stored procedures, and you don't need any other triggers or secondary indexes? Okay, so just because of number of requests, just because of velocity, your existing database is rendered useless. And these databases who provide you all of these features, when you don't need those features, why do you need the slowness of a single database? And that's where these new databases were born. And these are called NoSQL databases. So a NoSQL database is for handling huge data, high availability, meaning in case there are a million users on your website, you can cater to them. Scale out architecture, meaning using commodity hardware, you instead of expensive hardware, instead of blade servers, using these small servers, you can combine them together and prepare this architecture which can be used by which can handle humongous load. And that's the reason why you need NoSQL databases. All right. So what is a NoSQL database? NoSQL database, the main thumb rule of a NoSQL database is that it is distributed. Okay, it is distributed, and you can see this picture. Okay, in this picture there is one cart, but it is being pulled by so many animals, and these animals are your commodity cattle, right, which you can buy. uh, I mean, which is available. It's not like certain high end and all that. So this picture demonstrate how can you use that. If you add more and more cattle, you will be able to handle humongous load. All right. So the first thing that a NoSQL database, the first characteristic of a NoSQL database is that it has got distributed database. Okay, it has got distributed architecture. Many computers work together to provide database. Many computers are connected together to provide that load handling capacity. All right. Now, when you have distributed architecture, when you have multiple computers and a table is being divided onto multiple computers, when a table is being divided onto multiple computers, you need to identify each record. Therefore, an ID for the record is must in all NoSQL databases. Most of these NoSQL databases are non-relational in nature, because if you start having relations, again, the sloppiness and that restrictions start coming into place. Okay, therefore they are non-relational. They're schema free, again, because we don't need too much of schema in case of fast-paced data, fast-paced number of requests and fast-paced modifications. They manage use data, and they run on commodity hardware, and they are horizontally scalable. Today you have 3 machines. Tomorrow, if you have 10 machines, you can keep on adding them. Next is the open source, because whenever there is a database, they will not get accepted by the industry if they are not open source, because your data get logged inside the database. And therefore, to avoid vendor lock-ins, people prefer to pick up the database which is open source. Okay, there are 4 general kind of NoSQL stores. One, column oriented. Second, document oriented. Third, key value pairs. Fourth, a graph. Okay. So column oriented means you have got many columns. They are the closest cousins to our relational database. Document oriented are those such as MongoDB, where we store document. One record is a document. Okay, though all of these NoSQL stores store a record, the only thing that varies is the definition of a record. Okay, definition of a record. In case of a normal column oriented one, it's the each each record each record looks like a table, but there is a difference. We will talk about it later. In document oriented database, each record is an object, or you can say document. What does it mean by an object? An object is a collection of key value pairs, like a hash map or a dictionary. Okay, and each value in the dictionary can further be the object, and so on. Or each value or any value could be a string, integer, array, or another object. So that's a definition of a complex object in the form of JSON. All right. Then you have key value pairs. Key value pairs were the most primitive databases When Amazon on one of the years, Amazon has a very bad Christmas because their website got shut down on the Christmas, and then they said they came up with they bought a lot of hardware. They went crazy and they bought this humongous hardware and said that we don't want this kind of crisis next Christmas. Okay, so what they did instead of utilizing, you know, so much hardware, what they did was they came up with a system like Dynamo. What did Dynamo do? Dynamo was a key value store in which there were only two columns. You could always imagine Dynamo as containing a table which has only two columns, or an Excel sheet with only two columns. First column is called key, and second column is called value. You could quickly look for key and update the value, but for finding the value, you might have to search in this table. Okay, so you carefully choose your key and put the values. Value could be anything. All right, so those were the key value pair kind of database. Okay, next is graph database. Graph database are fairly new and they handle the complex data in the form of graphs. Is everybody with me on this? All right, so this is a classic difference between SQL databases and NoSQL databases. All right, now let's talk about something more important called cap theorem. Although we are pretty happy that we are able to handle huge load, but none of the none of the NoSQL databases are able to give you great amount of consistency. All right. So cap theorem says that out of consistency, availability, and partition tolerance, CAP, out of the three, only two can be availed at a point of time. Only two can be availed at any point, either CA, CP, or AC. But not all the three. All right. Consistency means all the clients or all the nodes have see the same data at the same time. Availability, a guarantee that the request get answered. Partition tolerance means if some nodes go down, or if if there is a disconnection in the network, still the system continues to operate. All right, and why is it so? Let's try to discover and let's try to understand why the cap theorem is valid. Why CAP cannot be guaranteed. All three CAP cannot be guaranteed. Only two of them can be guaranteed. So this cap theorem is also called Eric Brewster's theorem, and this diagram will try to answer that. This diagram will try to answer that. All right. So you can see that on one hand you have RDBMS. So in case of RDBMS, there is only one machine, and this machine is what user access. Okay, all the users write to this machine, read from this machine, and that's end of the story. Now if this machine goes down, neither writes nor reads can be catered, and therefore an RDBMS is not a great solution. Okay, an RDBMS is not available because it's the bottleneck. Okay, there is a bottleneck, the number of users it can cater is very small. Okay, Rawls' question is, what is a partition tolerant mean? In case either when we say message loss, if you look at the description, okay, it says the system continues to operate despite arbitrary message loss or failure of the part of the system. Meaning, in case there is a failure, maybe some nodes shut down, some network was unplugged, some cable was cut between the two network, and still, if the system continues to operate, that is called partition tolerance. Even after network partition, if your system is happily performing, that means your system is partition tolerant. You will see the exact meaning of it as we proceed further. Good? Let's take a look at the second one. So RDBMS is not available because only one system is there to cater to all the users. If there are thousands of users at the same time, only few will get answer, right? In case this one machine get disconnected from the network, then the users will go empty-handed and we cannot cater to the users. Now, let's take a look at the second one, the middle one. Okay, the middle architecture. In the middle architecture, what you see is there are two machines A. There are two machines A and B. The writers always write to A, while readers can read from A or B. Okay, so there is only one machine on which users are writing, while reading can happen from both the machines. There could be A, B, and C, but still only one machine called A would be for writing, while B and C could be used for reading. All right. So here, although you can see that there are two machines to respond to users, that means it is more available architecture than the previous node. Second, it is partition tolerant, meaning if one node shuts down or the network get unplugged from one of the nodes, there is another node to serve the users. Okay, but while this architecture is available and partition tolerant, it is not consistent. Why it's not consistent? Okay, there is a time lag between data being available on and data being modified at A. If a user modify the data at A, it will take some time to reach B. If in the meantime, if the same user came who updated the data and checks it on the B, it will say that the data is old, and that will assume that your server is really inconsistent because he made certain change, and that certain change is not being reflecting at B yet. Okay, so it takes time for the change to propagate, and therefore it's not strongly consistent. Instead, it is eventually consistent. Eventually everything is going to be all right. The changes we made at A would reach B, and therefore it's eventually consistent, not strongly consistent as opposed to the relational databases. Okay, so the definition of partition tolerant is clear to you, Raul? All right. Next is the edge-based kind of a model. The first one is RDBMS kind of model. Second one is MongoDB or Zookeeper's kind of model. Third one is edge-based or kind of model or name node kind of model. There is a machine A. There is a machine A to which readers and writers both talk, while there is a backup of the same machine. While there is a backup of the same machine, which is being replicated and kept. All right? Meaning, if A shuts down, we have B. In case B shuts down, we have A. Right? So this is kind of partition tolerant. But since all the reads and writes are happening always on one machine, like in the case of name node, all the first requests go to the name node, and therefore name node is generally the bottleneck, right? So in order to have consistency, we had to let go of availability. Let's take the case of HBase master. We will talk about it. There, the data is again strongly consistent. All right. Next is the column-oriented database. So before we start with HBase or NoSQL, let's understand the definition. And most of the topics are generally about the definition and the philosophy. Okay. And so we talked about what is NoSQL database, what exactly happened, which triggers the need of NoSQL. And we also talked about horizontal scaling, vertical scaling, scaling up or scaling out. All right. The other definition that we need to understand is row oriented database and column oriented database. Okay. So when we represent something in the memory, when we represent something in the memory to a user, let's say when you look at a table in database, it's nice. It has nice columns and it has nice rows, but in reality, it's actually stored in the file, right? And a file is a sequence of bits. A file is sequence of bits stored in the on the disk, correct? Now, when this object you see on the screen, when you convert it into the row of bits, row of zeros and ones, how would you save it? Should we save the rows first or should we save the columns first? All right? And that's what makes the difference between the orientedness of a database. Okay? Although it's the same table, for the end user, it looks like a table. But in case of row oriented database, like we store first the row, let's say 10 Joe, 12 Mary, 11 Kathy. That's row orientedness. And the second is column orientedness. We store 10, 12, 11, Joe, Mary, Kathy. Correct? That is column orientedness. That is column orientedness. Does it make sense to you? Like when you look at the CSV file, you first store the first row, then new line, the second row, new line, third row, new line, fourth row, and so on. So the whole table structure is being saved as a straight single queue of characters, right? This is basically called serialization, converting an object into row of bytes. That's called serialization. So here we are seeing that either serialization can happen first columns or first rows. And that's the difference between column oriented database. Now, HBase kind of database were very clever. Yes, Raul, that's correct. Thank you for noting that down. So yes, so in this question, what you see here is when we say 001, they are kind of record numbers. They're kind of record numbers which we are marking them so that we can use them. All right? We are kind of marking them so that we can use them. All right? Internally, generally, we keep these pointers or markers so that we can dereference. All right? Good. So these are kind of markers marking the row or the column. All right? Did I make sense to you? Great. All right. Now, H-based kind of systems were kind of very clever and were very politically correct. So they came up with a strategy called column family oriented database. These column family oriented databases are something in which a column family is stored first, then second column family, then third column family, and so on. It is must to define the column family in a table. Okay, so first column family CF will get stored first, then second column family. Okay, meaning this data will get stored first, and inside the column family the data gets stored row wise: 10 Joe, 12 Mary, 11 Kathy. After that, this data, which is second column family, gets stored after CF1. Okay, 23, 33, 45, 23, 33, ignore the row markers, and 45. These are the row numbers or column numbers. All right, this is called column oriented database, column family oriented database. A column family is made up of multiple columns. Okay, and when this column family oriented data table is stored on the disk or serialized, it will get converted into something of this sort. Okay, 10 Joe, 12 Mary, 11 Kathy, and then 23, 33, 45. Good? Does it make sense to you? Now, let's take a look at how does it help. All right, using column family oriented database, we can actually use it as a row oriented or as a column oriented. Let's take a look. All right, now let's take a look. Imagine in the first case that in this table there is one column family per column. So when the data gets stored, it is stored as row oriented or column oriented. Yes. So first, can somebody help me? So this one is a row oriented or column oriented, the first one. This one. A column family is stored first, and then the rows of it inside each column family. Pavan and Akash says column oriented database. Anybody else? What is a column oriented database? A column oriented database is the one where columns are stored first. First first column gets stored, then second, then third, then fourth. And a row oriented means first row, second row, third row. Column family store databases are those in which a column family gets stored first, and inside a column family it is basically row. Inside each column family is stored row wise. All right, anybody else? Is it a column family oriented database or a row oriented database? Correct. This is a column oriented database. CF1 gets stored first, which means this one, then this, then this. Okay. Now take a look at the other one. There is only one column family for all the columns. Okay. There's only one column family for all the columns. Okay, there's only one column family for all the columns. In this column family, CF1, you see these three columns: employee ID, name, and age. Okay, right? Here, do you think it's a row oriented or column oriented database? So, this CF1 when gets stored, yes. Second one will act as a row oriented database. Now, that's the cleverness of HBase. Good, very good question, Akash. Let me just keep this question on my queue. Okay, let me take a look at a deeper look at this. All right. The bigger question here is, what is the point? What's the point of using column oriented database while row oriented database work just fine? We store data using row orientedness. Okay, because in one in case of row oriented database, it's easier to append rows. In column oriented database, it's easier to append columns because last column will come at the end of the file in case of column oriented, and last row will come at the end of this one. But adding a row is difficult in column oriented because every record has to be modified, and adding a column, one more column, would make changes to all the rows. Let's say we had to add one more column here, then what would happen is we have to modify end to end, correct? So while in row oriented databases adding a row is easier, same is difficult in case of column oriented database. All right. Good. Everybody clear about row oriented and column oriented database? All right. Now let's talk about advantage. What's the point of using column oriented or row oriented? Okay. So even though adding a record, or it might look that okay fine, in column wise adding a column is easier, but again adding a row is difficult, correct? The reason is, few of the scientists or few of the engineers found that found that column wise column by store is generally more space efficient, meaning this when you compress this you get better result. Why? Because these numbers generally are similar numbers together, because in a column all the data is generally of similar type. For example, employee ID is similar, and similar data when you compress gives you a better result as compared to non-similar data. Here it's number, then Joe, then Mary, then 11, and then Kathy. While if you compress this data first and this data second, you will get better results. So they empirically found that if you compress column wise, the result is far more efficient, as far more space efficient, meaning it is a better compression. All right. And the way compression works is finding the commonality which is being repeated again and again, giving that commonality a symbol, and then using that symbol again and again. All right. That's how compression works. So the main reason behind the column oriented database, column family oriented database, or any of this thing is basically for making it more space efficient. All right. Does that answer your question? So Ravichandran's question is, how do you read data in column oriented database? The way you read data in column oriented database is generally column wise. Okay, but again, most of these data stores provide you API to do query. Okay, and generally the API is same for both row and column. So this row orientedness, column orientedness does not impact the API. It is only for the internal purpose. It is only for the storage purpose. It is only for making it more space efficient, making it better compressed. We use these orientations. Otherwise, the API will remain the same. Okay? All right. So what is an edge base? So Ravichandran, was I able to answer your question? All right. So let's talk about HBase. HBase is a NoSQL database which is column family oriented, and it is CNP. It is consistent and partition tolerant, but since there is one single machine through which all transactions go, therefore it's not highly available but consistent. Out of CAP, it's only C and P, not A. All right. HBase is based on Google's Big Table. HBase is generally based on Google's Big Table. Okay, what does it mean? So so Google came up with a paper called it's called the there is a paper by Google. The title of the paper is the Big Table. Okay, it's a humongous table, and they used this kind of database for computing the page rank amongst many hyperlinks. Okay, it's great. HBase is good for hundreds of millions or billions of rows. Okay, and all right. Let me try to answer the question from Rolf once. Okay, before. Okay, I'll say better compression. Okay, compared to row oriented or column oriented is faster when searching for a record since it doesn't have to need to read entire row. Actually, when you are reading row oriented, you will basically have to locate where is the row in the data, and you might need to go through many records. All right. So yes, it might be marginally better. It might be very slightly better, not huge, but yeah, but it will be only slightly better. Space wise, column oriented is better if you are compressing the data. All right, good. Let's move on. Okay, so it's great for the cases where you have hundreds of millions of rows, hundreds of millions, meaning 10 to the power 8 onwards. If you have lesser than that, any RDBMS can help you. It's strongly consistent, not eventually. Okay, it provides automatic sharding using something called region servers. All right, there's always a region failover. We'll go into these details. It is strongly integrated with HDFS and provides massively parallel processing using MapReduce. It provides an API via Thrift and Java. It provides coprocessors and Bloom filters. Right? Let's try to understand the basic diagram of HBase. Okay. All right. Let's try to understand what does it mean by by HBase. Okay. Let's try to understand the architecture. At the bottom, you see HDFS and you see Zookeeper. We will go into Zookeeper after a while. For time being, you can think of it just another kind of a whiteboard on which people can write their name and some people can read that. Okay, so that's Zookeeper. We will talk about it later. So at the bottom of HBase, you have HDFS and Zookeeper, and HBase first interacts. Uh, Basically, HBase is composed of one master and many region servers. There is one master and there is region servers. All right, and then it provides an API for making the calls. All right. Now there is a single master and there is a region server. All of these are interacting with each other or are discovering each other via Zookeeper cluster. Region server 1, these are all machines and they are installed on multiple machine. While master is a single node, there are many region servers just like name node and data node. Region server, sorry, region servers are Region servers are for storage of the data, while master just keeps the record of what is where. Master keeps the record of which record is on which machine, and region servers keep the actual data in the HDFS. Okay? And region servers give their attendance to the master continuously via Zookeeper. Alright? So when uh, when certain data when a user comes to master saying that hey, I want to create a particular table, it assigns one region server, and on that it can create user can create a table. All right, all right, let's take a look. All right, let's say there is a master here. This is our master. Okay, there is a region server R1 and there is another region server R2 and there is a third one. I think I'll use another tool. All right, I'll just quit this one. This doesn't look that good. All right. So let's take a case that this is a master. This is our master. Okay. And this master is the basically kind of a supervisor while we have one data node. Okay. So we have one region server, region server. Okay. And there are many such region servers. There are many such region servers. Okay. So the user comes to the master, and then user is redirected to either of the region servers. All right. So here, the way the data is stored is in the form of regions. Initially, when a first table is created, it's created on only one machine. Okay, it's created only on one machine. Let's say you created two records, it will be created only on one machine. Okay, now you started adding more and more data to this one. Okay, you started adding more and more data here. Okay, now the moment the data grows beyond certain values, it is basically each region is split into two. So okay, so now there are two regions. These are equal halves. Okay, they are cut into two halves and they are sent to uh, another machine. Now you have two regions, region 1, region 2. Okay, and you can think of each row as a record right now. All right, now the way we define a region is that it is starting from certain value and going up to certain value. All right, similarly we are starting from C, let's say going up to Z. Okay, we are going up to Z, so this is from A to B, this is from C to Z. Okay, and as and when more records are being added, more records are getting added to it, we are adding more records to it, and we are basically writing more and more records, adding more rows to it. Similarly we'll be adding more rows to it, and let's say we are adding some more rows and so on. After a while, again it will split into exact half. Okay, it'll split into exact half. Okay, and then it will form another region, maybe on another machine. Similarly, this will also break and will form one more region, let's say on maybe same machine. Okay, maybe on same machine and so on. All right, so basically initially you load all the data into a table. HBase internally keeps a single region initially. All right, a region is defined by initial ID and final ID. So, and the table in HBase is ordered by ID. Therefore, therefore the data in the region is also ordered by ID. Here it's A, B, then C, C1, X, Y, or something, and so on. All right. So now master keeps a track that all the records starting with all the records starting master is keeping the track, like all the records from A to B are here in this one. All the records from C to let's say C to R. Okay, C to R are in this region. Okay, and all the records from R to Q are in this one, and so on. So basically master is keeping track of ranges of IDs, and it's only keeping track of ranges, like each region is, because the data is ordered by ID, Every row has a ID and the value. Does it make sense to you? Do I need to explain again? I'm all right if you want me to explain again. Does it make sense to you? Yes, master is more of indexing and does not store the data. It basically keeps a track of range. Okay. In HBase, the important point to note is, as we have already told, that in every NoSQL, ID is mandatory. For every record, primary key is needed. Okay. You might want to generate it automatically or come up with a plan of having unique ID. Okay, so initially you create, when you say create my table, add these 20 records, it'll create a single region and put those records onto those a particular region server. And as in when you will keep on adding more and more records into this table, this region will keep on becoming bigger and bigger, and it has reached a threshold after it has reached the threshold, it will be just sliced into two equal halves. Some some in one region and some are another region. Alright? And each region server could contain many regions. Each region servers could contain many regions even for the same table. Okay? So I hope that answers your question, Pavan, that when the size of the data grows bigger, master will ask region server to split the data. So Akash is saying how okay, Akash is saying it works above HDFS or it is like HDFS itself. This reason, okay, the HDFS is this reason being stored into HDFS. Okay, this is being stored into HDFS. Okay, make sense to you? Every piece, these are pieces of your actual table, or these are actually portions of your big table. Now, question from Anil is, how is partition tolerance achieved? Okay, let's take a look. How is partition tolerance is achieved? Let's say this machine goes bonkers. Okay, this machine is no longer alive and it has been off went offline. You can spin off another reason because this data is anyway in HDFS and will be automatically started. Okay, so the same reason will move to some other machine because this has gone down. That's how the partition tolerance is achieved. Okay, good question, Anil, Akash, and Rol and Pavan and Akshita. Okay, so keep asking questions. These are the real questions, and okay, because there are certain things which I might assume that you all know. Okay, but things might look okay and very simple to me because I have been doing this for quite some time. Okay, but please feel free to ask right away. Right, I to get a idea about whether I explain certain things well or not. Okay, all right, great. So this sketching looked ugly to you, or did it make sense to you? The handwriting is really, really poor. Anil's question is, can master not talk to region server directly? from the diagram, it doesn't seem like the case. Okay, the master could have talked directly, right? But there's too much of overhead. If you have a great service like Zookeeper, then you can use that one. Okay, all right. So Zookeeper you can think of as a whiteboard where everybody writes their name, and they give the attendance by writing their name in Zookeeper. All right. So region servers stores immediate data that is also in it. So region servers do not have any data in the memory generally. They do cache sometimes, but that's too. I mean, we avoid it totally. Okay. So region server store immediate data in the HDFS. Okay. The whole region is stored in the file system called HDFS. All right. Good question, Patrick. Okay. So now let's go through these definitions, and then we will try to understand it further. All right. So a table is automatically divided into regions. By default, there is one region in a table, and afterwards it keeps breaking down into multiple partitions. Okay, so each region comprises a subset of tables rows, and then it is basically denoted by starting and end. Why it is sufficient to just mark a region by starting and ending? Because the data in table is ordered by an ID. Okay, therefore if you have seen in the dictionary, at the corner of the dictionary you will see that what is it that is contained in a page, and that's just two words, starting word and ending word. Here a region is defined by table it belongs to, the first row as in first row ID or row key, which is inclusive, and last row which is exclusive. Okay, meaning the last row ID is in the next region. Initially, every table starts with a single region. As the region grows, it is split into two equal halves. Until the first is split, all the loading of the data happens on a single machine. As the table keeps on growing, number of regions grow, and the ability to write data keeps on becoming more and more parallel, right? Because if you have more regions, you can modify more number of regions parallelly, and so on. All right? Multiple people can modify a region parallelly as long as no two persons modify a particular row at the same time. Gizi's question is, how, was I able to answer, Patrick, your question? So, yeah, all right. Let me try answering Gizi. How the data in the region server is replicated. Okay, how is the data in the region server gets replicated? Okay, so the region server has got file, and each region is persisted as a HDFS file, and this HDFS file is anyway replicated on three data node. Okay, and that's how the data in the region is replicated. Okay, Does it make sense to you? I missed so many questions here. Let me just note it down so that we have the records here. All right, good. Okay, so this is the logical view. You can see that, you can see the physical layout. So on one end, you have this kind of indexing, which is done at the master level, HBase master level. Certain pieces, certain ranges are on individual regions, and you can also see that all the keys starting with A to C is existing on this one, and so on. So if a person comes and they want to insert a key which is between A and C, let's say B1, okay, let's say B1, the data gets appended to this particular region. If a user comes and they try to modify this particular region, they will basically modify this. Okay, let's say somebody is trying to modify, create a key or modify a key called L. The call will go to this particular machine. Right now, you can see that there are six regions, and these six regions are being catered under the hood. Each region is being stored in HDFS file. All right. Now, the kind of data model HBase has big table kind of data model, is a sparse, distributed, persistent, multidimensional sorted map. Each word mean a lot. It's a map as in it has key and the values. Sorted, it's ordered by, meaning this map is ordered by the key and the value. It's ordered by the key, not the value. Multidimensional, as in the value could have more and more and more and more records, okay, more and more columns. While it's persistent, meaning it's saved onto disk, it's distributed because it's on many region servers, and it's sparse because all the rows don't need to have same number of columns. Okay, we will go into the data models again. Before that, I'll try to answer these two, three questions. Okay, and let's take a break before that. All right, let's take a break for 10 minutes. Back by 9:45 p.m. IST. All right, so I'm back, everyone. All right, so should we start now? Okay. Okay. Next question from Ravi Chandran is: first row is inclusive and second row is exclusive. Okay, that means when I say first region contains IDs from one, okay, one is inclusive exclusive and 10 is exclusive. Okay, meaning or let me just put it, say 5. So first can have 1, 2, 3, 4, but 5 will be in the next data set. Okay, next reason. All right, a region server, when we say from 1 to 5, 5 is not exclusive, it will only have up to 4. Okay, 5 will generally go to the next region server. Okay, so it will have 5, 6 and 7, not the 8. All right, and 8 will be on the next one. Does it make sense to you? So here 5, it is 1 is inclusive, 5 is exclusive. All right, so a question from Gizi is, so server 2 goes down, HDFS will give data from the replicated block. Yes. Okay, it is there in the HDFS. Can a region contain records belonging to different tables? Yes. So no. So but a region server, a region server can have multiple regions from same or different table. Okay, was I able to answer your question? It says nil as your name. Anil. Oh, okay, I'm sorry. Yes, while copying I missed. Next question is from Pavan. As the region server stores data in HDFS, it may have to edit the data in HDFS file, just not append. Very good question, Pavan. So the way it happens is each region, okay, each region is in the file system, right? So when you modify a region, if you are just appending a region, then so this file is getting modified. In these cases, generally HDFS file is either rewritten. Also, HDFS file contains padding so that the modifications are put into the padding space. Okay, and we do not have to rewrite. Okay, but if padding is full, then you might have to rewrite the region. All right. Okay, so a quick question from Raul. So was I able to answer your question, Pavan? Great. All right, next question from Raul is regarding pig. In pig, for the bag of map data type, how do you distinguish between different tuples when firing a query? Like sometimes we use hash and sometimes we use dot. For example, in the PowerPoint slide, we mentioned average equal to this, and then somewhere else we said this. Correct, correct. So when we want to dereference a particular key out of the map, okay, for map, when we want to dereference a particular key out of the map, we use hash, and when we are dereferencing tuple, we use dot. Okay, so the way you can take a look at is one, you can take a look at describe table that should give you the idea about table, or describe formatted on a table, or you could look at, you could look at the actual data, could look at the actual data before loading the table. Okay, there, if a particular column looks like uh, this, okay, that means it's a map. Okay, that means it's a map, it's a map. If it looks like this, okay, or let me say this, and okay, then it's a tuple. Do I make any sense? All right, all right. I hope I have answered your question. Okay. Next question from Patrick is, okay, I'm a bit unclear. I'm a bit unclear about what reason server stores versus HDFS. Okay, region server being a physical computer with memory, right? Yes. Okay. Okay, that's correct. Its memory store, its memory stores table of key and value being the data. Yes. No. So the actual data is actually in the disk. Okay. The actual data is in the disk. Each region is not each region is stored in multiple HDFS files. You will see further that for each column family, for each region there might be multiple column families, right, inside a table. For each column family, it's going to create one folder. Therefore, each region, when we say region, internally, each region server contains a mapping between region and the actual file. Okay, the actual file. So basically, the region server does have a limited amount of cache, limited amount of caching of the IDs. Okay, limited amount of caching of IDs. Actual data, actual data is always in HDFS. Okay, so it has some amount of caching plus mapping between the IDs and the HDFS files. Okay, so it has this relationship between IDs and HDFS files, not blocks. Blocks is something internal to it. Okay, did I make any sense to you? So the region server is kind of stateless. If you kill the region server, you have not lost any data. The data is entirely in the HDFS. Every region is converted into multiple files. Each region might have set of rows, and every row, some part, half of the part might be in one column family, half of it could be in another column family. So a region is composed of multiple HDFS files, and HDFS file is anyway saved in HDFS. Okay, great set of questions. I'm really liking this. And all right, just continuation of my question. Even if you have padding, the file may have to be rewritten. Yes, that's correct. It could be that data you are inserting might exceed HDFS block. That's true. Can you explain from HDFS block perspective about this writing? Okay, so all right, the region in case of HBase, you can always imagine that to be composed of multiple files, and whenever there is a modification in certain section of the data, it will try to avoid rewriting of the files, but the rewriting of the files would invariably happen. Okay, since individual HDFS files are uh, I mean are rewritten. Okay, if the record is being appended to a region, it's okay from the HBase perspective. All right, this is true. Okay, so whenever you modify an HDFS file, generally you end up rewriting the file. So the way most of the database, okay, let me try to demonstrate. I think that will be better. Okay, that'll be useful for everyone. Okay, imagine this. Okay, imagine this. There was a file. Okay, or there was a table which has certain set of records. Okay, let's say that it has three records. Okay, and it has one column ID, which is okay with everybody, and let's say it has earlier only a small string, let's say s, and this is y. Okay, internally this is 1 and this is 2. Internally it's going to be stored like 1, then a marker, some kind of a marker, then s, then some kind of a marker, say comma, then 2, some kind of a marker, and so on, right? Now, if we try to modify it as a, this whole thing has to be rewritten, correct? This whole thing has to be rewritten. All right, this whole thing has to be rewritten. That's what is the main question. So you'll have to now write this way. So what do generally databases do? They reserve a space, so they'll write 1, and then they'll reserve some space for more value, and then they'll reserve more space for SA. Similarly, they'll reserve some space for 2, and they'll reserve some space for Y. Good. All right, they'll reserve some space in the disk for every value. Based on the data type, they generally reserve this space. So you can modify this without making any change. All right, so same thing, the this HBase also tries to do, I think it uses HDFS's native library so that it can directly edit blocks instead of rewriting the whole file. Okay, this is what HBase also tries to do. But in case, let's say you have crossed this boundary, and let's say we are trying to store Giri. In that case, all of these things has to be moved a little bit, okay, and then Giri will have to be written, correct? In that case, the file is kind of almost again rewritten. All right. So I think, as per my understanding of HBase and HDFS interaction, HBase does try to modify the data on the block level rather than file level. That's why it's able to achieve the good performance. All right. All right. Pawan's question is, then the replications also need to be taken care manually by HBase in that case? Yes, kind of. But maybe they are using a set, because I am also thinking the same thing. Because in case they're modifying the actual blocks directly, then the same block has to be copied to others, right? Instead of the whole file. Therefore, the dynamics is little complicated, and uh, I think in this case maybe the whole block is dropped and new blocks are created in case of replication. Probably for replication they are just copying the block rather than modifying it. Okay. A question from Patrick. If the region server is stateless and contains the mapping between IDs, okay, the SDFS, then how does it recover its mapping? That mapping is also saved in the HDFS file itself. H file contains this mapping as well. All right, very great set of questions. Okay, so generally this information that, so the way it happens is that I'll show you the actual data, then you can understand that a particular file is how this file is organized. Okay, and this mapping is essentially governed by HDFS itself. All right, it's basically governed by HDFS itself. Anil's question is, master also contains mapping information? Yes, master also contains mapping information. Here, the mapping is basically not between IDs, but mapping is between which column family is in what file. Okay, which column family is into what file and so on. Okay, so that mapping is very straightforward and very simple. All right, great set of question. Pawan, was my answer clear? Actually, yeah, that requires a little bit more, look into what is it they are doing. All right, all right. Let's try to understand how does the data model differ from other systems. Okay, so the first thing in the data model we need to understand is a table. Table is a standard table. There's nothing much. Just that for each table there is a folder that is created in HDFS. So the table name has to be safe. Then table contains rows. These rows each have their unique identifier called row key. Row key do not have data types and are treated as byte array. Now you'll be amazed at this fact. You'll be amazed at this fact that in Roki you can store gigabytes of data happily, and that too in the binary format. And this gave me a surprise. In one of our data models at InMobi, which you are trying to store, we actually stored around 10 MB data in the Roki itself. I was thinking that Roki would be nice, and would be like a string, and we'll be using that. But interestingly, Interestingly, we stored big data, as in 10 MB data, in the Roki itself. Okay, and there are many use case of storing data in the Roki itself. All right, all right. So the table is ordered by row keys, and the sorting is byte by byte. Then comes column family. Data within a row is grouped by column family. Column family impacts the physical arrangement of data. They must be defined upfront and are not easily modifiable. So first abstraction is a table. Table contains rows. Rows have regions. Rows have column families. Okay, rows have column families, and every row in a table has the same set of column families, but it does not need not to store data in all the families. Okay, all strings that are safe for the use in file path can be the name of the column family, because it is going to create one folder for column family. Okay, then comes column. In each column family, you can keep on adding more and more columns. The way you add rows in your table, you can add any row, right? In the same way, in HBase, you can also add column. You can keep on adding column, just like row. Just like row key, we have column header. Every column is identified by the name of the column. That's called column qualifier. Column qualifier does not need to be specified in advance, and column qualifier does not need to be nice strings, clean strings. They can be binary data. They can be binary data and are always treated as array of bytes. All right. The cell Each cell is, so we have what all we have table contains rows, and rows have column families have columns, and each column contains the cell is the actual place where the data is stored. Cell have versions. Okay, cell have versions, meaning last three four values of a cell are versioned, and by default the version is a timestamp. If you do not specify the version number, the current date or time is used. All right, the number of versions retained by HBase is configured for each column family. The default number of cell version is 3. This is how you can think of these definitions in the ideal way. In the best case scenario, this is how it will look like. So you have table has column families, table has rows, every row has row key. Column families have columns like personal. There are two families here, personal and office. Inside office you have phone and address, and inside personal you have name and residence phone number, and the table contains rows, and the row key is 0001, 0002, and so on. And each of the value, like here you see the phone number 415 111 and 1234. This cell has got many versions. Past three versions will be retained. Same thing, you can look at it in a logical way. Each row has column family. Column family has got columns. Every column has got cell that has got multiple timestamp, and then the cell value. All right, now let's take the real case scenario in for the data model. This is the reason, this basically from the paper on the big table, and this is a very good example. So Google crawls data from across the world, right? Google downloads everybody's website and makes a note of who is referring to who in what way. My website is linking to your website with a name, with certain name, okay? Or your website is linking to our website with a name saying big data classes. All right. So these kind of information is extracted by Google Crawler and is maintained. It is maintained in the big table. And let's call this particular table as web table. All right. So every time Google hits a web page, it downloads its data and it creates a row in this table. Correct? It creates a row in this table. Afterwards, it tries to understand that HTML and tries to infer which this newly downloaded page is linking to. And then it goes to those particular rows for each of those links and then mentions that this particular website is linking to you with this name. For example, in this diagram, row key is the URL, inverted URL, okay, com.cnn.ww is the row key. While it has two column families, one is contents, other is anchor. Contents have a single column with empty name and it contains the actual HTML. And for everybody, for every URL which is referring this particular URL, okay, is creating one column inside anchor column family. For example, cnnsi.com is referring to this particular page with a name called CNN. My.look, my.look.ca is also referring to this particular URL by the name cnn.com. Okay, if there are 1,000 websites linking to this linking to this particular URL, there'll be 1,000 columns. All right, that also means that this table will increase horizontally as well as vertically in the same manner. Correct? And will be sparse. You might ask, why do we need this kind of table? Why does Google need this kind of table? The simple answer is the page rank. Page rank is computed by counting who all is waiting, who all is linking a particular website. If more people link to your website, that means your website is more important, and more important people link to your website, you become further more important. All right, if very useless websites are linking to you as opposed to the other websites which have higher page rank, okay, so basically the page rank you gain is a function of how many is the summation of the page ranks you you are being linked by. If my website is linked by, let's say, apache.org tomorrow, suddenly my website will start coming up in the list. So out of all the criteria, PageRank is one prime criteria. Okay, out of all the criterias to give the listing, PageRank is one criteria, although it's being discarded by Google these days. Okay, and all right. So here there are few things to note. Few things to note. One, the column name can be empty. Second, there could be as many columns inside a column family as you wish. On one end, you keep on adding rows, and on another, you keep on adding columns. It's both this. I mean, HBase is totally comfortable with it. Okay, every row is supposed to have a key, and here the key is inverted URL. Why? Because this table is going to be ordered by the row ID or row key, correct? Therefore, if you want to keep the same website together, you should be first comparing total TLD to top level domain, and then the actual domain, then the subdomain, right? So the data should be sorted based on first the top level domain, then the domain, and then the subdomain. So that so that I'll show you. So that okay, let's say we have www.google.com, mail.google.com, and let's say similarly blog.nobigdata.com. Okay, and we have mail.microsoft.com, and we have say www.nobigdata.com. Okay, now imagine that these websites are being crawled by Google, and an entry is being made. Okay, this is the row key. Just for a second, let's imagine that. What would happen, because this data is ordered by the row key, right? Therefore, the website would come in this order. First, it'll be blog.nobigdata, then Google, then Microsoft, then Google, and then no big data. So the data from the same website did not come together. Therefore, this is not a great scheme. Correct? Generally, we would like to crawl all the pages, or generally we would like to maintain the data ordered by the company websites. Therefore, if you make it something like this, if we try to say, let me use regular expressions for this kind of scenario. Okay, all right, we say $3 dot $2 dot $1. Okay, now if we have the data in this form, inverse form, and we sorted, you can see that Google has come together, no big data has come together, and Microsoft has come together, right? So here we are figuring out a key which will ensure that the data amongst the rows, the data that goes together in the region, is together in the basically we are trying to figure out a key to ensure that the data we wanted together stays together. All right, so that when we are reading a region, we basically can read the whole range of the keys happily. All right, when reading happens, we generally can always query HBase with the range of keys. We can say, give me all the keys starting from here till here. Okay, and it'll give you the region, and also you can traverse the region. Is this data model clear to everyone? No? So basically Google needs to compute what's the page rank of this one, and how would it compute? By summing up the page rank of cnnsi.com, mylook.ca, and so on. Do I make sense to you? No? The silence is a reflection of things not being clear. All right, feel free to ask if something is not clear. And also note that there'll be a billions of rows and millions of columns, or billions of columns, correct? That's why we need this kind of model. The other need we have is that our data from the same website should be together. The other need we have here is that we should be able to access and update each row's values. So Anil's question is, so column family cannot be modified because it's a row wise. Not really. Column family, you don't change. You just keep on adding columns to the column family. You can skip adding column to the column family. Okay. Column family is basically kind of layout. Okay. Okay. You can add as many columns as you want. Just that the name of column families you generally do not change. Yes, that's correct. It should be specified beforehand. Because the data is organized by column family physically. If you change column family or modify column families, that folders need to be modified. So it's not a great idea to keep modifying column family because that would lead to a major modification to the actual data. All right. Any other question at this point? So this is an example of a humongous table, okay, humongous table containing the data from all across the internet. Should I move on or do you have any questions for me? Okay, so you can basically see that, so for the same column family for different timestamp you have different values. All right, so again let's try to revise what we have learned so far. Indexing is based on the key that we all understand. The data is has a primary key called row key on this table. There is no such thing called a secondary key on the table. Okay, tables are sorted by row key. Each region of the table has sorted a, a row key space from starting and end. End is not included, start is included in the region, and end key goes to the next region. Everything in HBase is HBase table is stored as a byte array. Everything in a HBase table, whether whether it's the name of the row, as in row key, column name, cell value, all three things can contain binary data. Atomicity is guaranteed at row level, not on multiple row level transactions. Column families have to be defined upfront at the table creation time. Column qualifiers are dynamic and can be defined at modification time. Okay, they are stored again as an array, byte array, as a binary data, and all the data model operations return the data in, in the order, such as first the data is ordered by row key, then column family name, then column qualifier name, and then the timestamp, and okay, and the data is ordered timestamp descending, as in the latest data comes up first. All right, let's show you how does it look like to interact with HBase. Okay, So the easiest way is we open the console. So you can either go to CloudX Lab and say My Lab. Okay. Here you will see lab credentials. All right. Okay. You can basically log in via console as well. All right. So there are two ways to interact with HBase. One is via the console by typing HBase shell. The other way to interact with HBase is using Hue. Okay, you could go to query editor or data browser and say HBase. All right, so you could say new table, and then you could define your table, define a column family. Okay, add a column property if you want to say my maximum number of versions and other things. Okay, you could define another column family and so on. Okay, this is one way, and the other way is you can import data and then create the table. Right here you can check what's up. It shows that although it shows that two servers down and two servers up, the main reason is although the servers are running, it's very clear. All right, now so here it has got maybe 4 region servers, 2 are dead, 2 are alive. Now we can create a table. We could say, okay, we could say create table 4th June. All right, so this table has been created. If we say scan, okay, it says there's nothing in this table. All right, now the other way we can have a look at all the tables is by saying ls. Okay, ls shows there are so many tables by various people, so we can take a look at any table. All right, these are empty, so okay, so you can take a look at it. So there are these many tables containing the surname as, we can also use list with a regular expression. If you want to put a certain data in a table, we can use put, and then, okay, let's say we are saying here, put into this table, this particular row, this particular column along with column family and this value. So now when you scan this table, you get a row with a certain column value. Okay. All right. Okay. Again, we have added some more data to this table. Now you can see that there are 2 rows and there is this value. Okay. If you want to access a particular value from the table, you can use get. All right, you can use get. It says there is nothing in it, but if you say 2, then it will show you the data. Okay, it shows you the timestamp along with the data. Okay, to see what's inside the table, but you can say use describe. If you want to drop the table, you can disable and then drop the table. All right. If you want to see the status of a particular, okay, let me modify it. Okay, if you want to see the status of the server, you can take a look at it. All right. Okay. So you can take a look at what's the status of a master server, showing the version number, zookeeper information, and everything. All right. Good. All right. Now let's take a look at what happened physically. All right. Let's say so the basically the main data is stored at this place. Apps, HBase, data, default. Let's take a look at it. We could go to the file browser. Okay. Here there must be a table about us. This is the table. Okay. So this is the name of the table. There is a folder for this table. This folder contains the what do you say, reason ID. This is the reason ID. Okay. This is the reason ID. And then inside a reason, you have column families. Okay. You have column families. And inside a column family, you have this data. Okay. Also, please note that the information, as I was explaining to you, the metadata information, like reason information, okay, is stored in this file using protocol buffer format. Does it make sense to you? The data is still not there because it has not been flushed yet. It is still kept kind of in a temporary place. So now, since I have flushed it, there would be in the my column family. So you can see that at the top level, the data is organized by per table, then per reason, then per column family, and then inside each column family, you will see the actual file. Okay, so this column family contains data here at this place, and this contains the data in a binary format. You can see that this is basically in a data in the data. Okay, and you can see that there are a lot of padding between in the record. This is padding, this is padding. All right, Pavan, does it make sense to you? All right. Also, the information like where is the column name and other things are also in the header of this file. Good. Yes. Question from Akash is, how do we query from HBase? Can we use Hive and Piglatin for querying HBase? Yes. You can always say using HBase loader or HBase catalog. Good question. All right. So in this place, you first store table, then reason ID, then column family, then the store file. All right. Locking is the full row, not the multiple rows. Okay. While you can, so here it does not, HBase does not provide a query language. It only provides a very primitive way of reading and writing. Okay. It provides a very primitive way of reading, scanning, and writing. So to read the data, you can use scanner. These scanners are like cursors. You will have to close them after you use, and scanners return rows in the order. Users obtain scanners by using the command called hbase.getScanner, where scan is a parameter containing on what row to start, where to end, and which columns to return. Okay, and optionally a filter to be run on the server side. And every time you invoke next on the cursor or the RS, you will get it. It will trip back to another region server. All right. If you want to use get and put kind of API, you can do that from Java. It's a little ugly, but it gets the work done and is quite useful because many other file systems have adopted the same. So you could say hbase config create admin equals to hbase admin and so on. Okay. So this way you can read and write the data using Java. And if you want to execute MapReduce on the HBase, you can do so exactly in the same way we executed the mapper earlier. You define the way we have defined the mapper reducer earlier. We define a mapper by extending table mapper. We define a reducer by extending table reducer. And then the input to the mapper is every row of this table. Okay, every row of this table. All right, and then you have driver. Driver contains all the config object, then job description. Also, while initializing the mapper or reducer jobs, you could define the query to be run on the source table before the records are considered. So you can see that we are saying source table is this, the scan that to need to be run. Okay, the which columns do we want to be selected, and from what ID to what ID and so on. All right, so this way you can create the MapReduce stage. All right, and you can execute MapReduce using Hadoop jar, your MapReduce jar. That's all. All right, next is the Bloom filter. Bloom filters are good algorithm, or you can say good data structure for making the search faster. Bloom filter make the search faster, but on a very huge scale. Okay, so let me take a step backward. So a Bloom filter is a data structure. Okay, and why I'm discussing Bloom filter, because Bloom filter is, kind of a pet question for many interviewers, and people like to ask many questions on Bloom filter. Okay, and basically, the Bloom filter is a way of improving the search by offloading some work to another machine. And how does it do that? Okay, how does it do that? Let's try to understand. Imagine there was a machine which was overloaded by many requests. Okay, so you came up with the idea that let's have some kind of a preliminary check on the query. Okay, let the preliminary search go to one computer and let the actual search go to another computer. Okay, so so when the so instead of all the search queries overloading your database, instead of all the search queries overloading your database, you prepare kind of a preliminary search machine. All the queries go to that machine. That machine can confidently say no, but cannot confidently say yes. Why? Because it doesn't have the complete information. Okay, so it has prepared. So let's say there is a humongous data stored on the second machine, and okay, humongous names, let's say names of billions of people are in the second machine. All right, let's say name everybody's name. Just a second. All right, my mouse is not working. Never mind. So let's take a look at it here. Let's take a look at it here. All right, let's say there was this machine which had this list: Midli, Biswa, Mahesh, Mamta, Abhay, and there are 1 billion such names. All the requests are coming to this machine, and this machine is overloaded. So instead of that, what you did was you set up somebody a new machine called Bloom filter. You gave a very small list, just first two characters of each name, which means this will hardly have 26 into 26 these many names: my, bi, ma, and ab, right? Only few names, 26 into 26, only these names, 576 names. Okay, while this one has 1 billion names. And why would it happen this way? Because we are only keeping hash code, or you can say in this case, we are just keeping first two letters. So this guy, this Bloom filter, only checks that if the name starts with these two characters. Okay? This name starts with these two characters. If it does not, if the user is coming with coming in and says, "Hey, my name is, say, uh, let's say my name is mythology, myt, mythology," it'll say yes, yes, you can go ahead because I have your first two characters. Okay, but then when it says go ahead, it doesn't mean that it can go ahead. It means that it can go ahead for the actual search. Then it will be compared with the actual data, and there it will be found that there is no mythology, but there is Mithili. Second, if somebody comes as, say, Zoro, Z-O-R-O, and since Z-O is not here, or Z-O is not here, therefore he will be rejected immediately. Okay, so this Bloom filter is doing a great job of rejecting lot of false negatives. Okay, false, lot of spam. Okay, so if the Bloom filter will be able to remove a lot of redundant traffic. Okay, just that the for the cases where first two characters are matching, it has to be again searched. So it would look like that we have increased the burden on the system. Look up for Midley first will happen here, and then true will return. Okay, is Bloom filter clear to everyone? So in case where a user says, "Do you have key one?" Bloom filter would say no. The user will return back, and this answer is correct. But in case it says that yes, I have the key, the actual lookup will go to the main storage, and that will decide whether you have the key or not. It might be no, or it might be yes. So it's essentially Bloom filter is essentially a preliminary search using the hash code or some other technique. All right. Bloom filter can be configured per column family based. Okay. You can, while creating a table, you can define this attribute, or you can at later point of time you can update the descriptor of the table by setting the Bloom filter type: none, row column. If none, no Bloom filter will be there. If row, the hash of the row key will be added to the Bloom on each insert. Okay, So you can basically create Bloom filter either on the row ID or row or the column ID combine. Okay, and and you can also skip creating Bloom filter. By default, Bloom filter is created on row key. All right. You can also define coprocessors. Coprocessors handle modification and updation of the data just like triggers. So you can define coprocessors using Java code like this. And after you have defined this Java code, you can export it into jar, and then you can define either in the hbase site.xml and restart the server, but that's not the option generally. So you update the table descriptor with the name of the class. Okay, so that way you can basically update the coprocessor without restarting. All right. HBase also provides you a REST-based interface. You can use REST-based interface happily using any of these commands. Using this command. First, you have to start the HBase REST server, specifying a port. Here, I'm using this particular port. We have to do that on the shell. Okay. So it has started the REST server. We can query our our table using this. Okay. It looks like this port is blocked. Right, let me try on some other port. Okay, let me try on some other port. Let's say I'm trying on 4040 port. Okay, 4040. All right, it says that table not found. What was the name of our table? Do you remember the name of our table? Yes, it was my table for June. Okay, my table for June, and so on. It says not found again. Why? Maybe the table contains my column family, my CF, and then row 1 or row 2, my CF. It says column not found. Just a second. What was the name of the column again? Right, what was the name? You can see that the name is COL2, my CF, row 1. Okay, row 1, my CF, COL2. Okay, so you can see that it has downloaded this data called 1234. All right, why it has downloaded? Because it's expecting the data could be in the binary format, which cannot be displayed in the browser. Therefore, it's letting it download. Okay, so you can access the HBase via the URL as well. Okay, if this data is in the form of JSON format, you can access it from here and embed it on website. All right, so this way you can access the HBase from the URL. Next is that the next is the JDBC. If you want to query the data from the JDBC, you can use phoenix.apache.org, which converts the query, which basically lets you access this data using JDBC. All right. So that was pretty much about HBase. Do you have any questions for me? There is a question, there's a basically assignment. Any question on? Yes? No questions? Okay. A question from Anil. Can you please explain Go processor again? Sure. All right. Let me go back once more. Okay. Let me first describe why coprocessor is used. Let us say you are building some kind of security mechanism around HBase. Okay, so what you would like to have is whenever somebody is modifying certain data or reading certain data, the control should come to you. Okay, and that's what coprocessor provides. You can write the handler pre or post handler. Pre handlers can deny any action. Post handlers would receive the update that something has happened. Okay, so for get and post and put and delete, okay, you have pre and post. All right, there are many actions that happen on an HBase table, such as get, put, delete. Okay, there are many such actions happen. You could either put a pre or post before get or put, and all right, and you can control those behaviors. So let us say here we are trying to execute our logic before get. So we are overriding a function called pre-get, and there we can say if access not allowed or some computation happens, if after checking permission we realize that the user should not be allowed, we can throw this exception. And this way we can use coprocessor for multiple cases. One, restricting access. Second, sanitizing data. Third, building triggers, as in if we want to update some other table after modification of first table, then we can do that. All right, good. Did it make sense to you? Okay, great. Now, so that was okay, that was a quick overview of HBase. All right, there is an assignment there. Assignment is, okay, the assignment is this one. All right, okay, there will be an assignment somewhere. Just a second. Yeah, HBase questions. Okay, here the here the question is this. If you have to design a simple Gmail like email storage and you have to store the data in HBase, what will be the tables? Okay, let's say your next role is to build Gmail kind of an email server. For that, you have to design the storage space so that when an email is received by some user, that gets stored in that database table. When user wants to see their emails, they can simply load the data and so on. So you have to build email storage using HBase. Okay, and you have to define what will be your tables, what will be the keys, what will be the column families, what will be the columns, and how many versions will you have, what will be the criteria for the versioning. Okay, so you have to basically describe it in the words. All right, and you have to describe and justify why did you pick something, right? So that's an assignment for HBase. That's an assignment for HBase. Okay, any other questions at this point? All right, is the question clear to everybody, the assignment? All right, any questions, any other question? All right, tomorrow we will continue, we will get into understanding of Zookeeper. We'll try to understand why and when to use Zookeeper and how to use Zookeeper. All right, and why it plays such an important role. We will cover few more ideas which are central to most of the big data computing. Okay, so we'll talk about those things during Zookeeper. All right. Also, if time permits, we will start our discussion on Flume and Scoop. All right. So thank you very much, and looking forward to see you tomorrow again at the same time. All right. Great. Great. Bye bye, and have a great day. Thank you all. All right. See you tomorrow, and have a great day. Bye bye.